Start. We'll see if anyone else comes. Hello, roomers. Hello, Zoomers. We have, let's see, we have formative assessment number 4 to go over. Before we do that, I wanted to open and ask if anyone has homework questions about homework 4. Not due until next Wednesday, so 8 days from now. I will warn you that many of the questions are essentially vocabulary drills. Trying to figure out what number tells you the piece of information in the question is the point, and then trying to find the number in the M+ output. Both of those things can be tricky. No questions yet? It is only Tuesday. It's to be expected. All right, my honorable TAs are going to come up here and lead us through the first 2 formative assessment questions, which I have on the screen share, but not this one. I love it when the smart board is anything but. There we go. That works a little better. All right, I've got the recording going.
Thank you.
So you should be good to go. I will leave the Zoomers are right here, and you can let them in if anyone else shows up.
Thank you, Lisa.
Thank you.
Hi.
Hi everyone. Happy Tuesday.
Yeah, happy garbage day.
Happy garbage day.
Yeah.
All right, so we'll get started here. I'm going to read off the first formative assessment question and guide us a little bit through that because we noticed some discrepancies in the answers, so we just want to go over that and make sure that's all clear. So for the first question, it says, in the IFA parameterization of factor models predicting ordinal responses, aka the graded response model, what are the definitions of the factor loading and threshold parameters? So who can tell me what a factor loading is? Yeah. Let me open up the chat here. So we have one answer in chat, logit of answering the higher category increased by every unit. Okay. Another answer here, factor loading refers to logit or probit, change in the item for 1 unit change in the factor. Right, so I'd say the second response speaks more true to the definition of factor loading there. I think the first answer speaks more specifically to the graded response model. Can you speak a little bit more to what you mean by higher category? Or if anyone in class wants to speak more to higher category, because this seemed to be a common response on the solution. Did you say scale?
Likert scale.
Likert scale. Mm-hmm. Okay. So in chat, we have further elaboration. It's like 1, 2, 3 category when we have 0 versus 1, 2, 3. Mm-hmm. And then the response option are binarized. I've never heard that. I like it. Oh, yeah. Binarized is the new one. I'm gonna have to use that from now on. And then it's the higher of the binary options. Higher of the binary options, do you mean the higher grouping or section of those categories? Okay, yes. Yeah, exactly. Great.
The slopes go the right way.
Mm-hmm.
The loadings go the right way. They go up.
Great.
Unlike anything else.
So who can speak to threshold parameters? Anyone in class as well? Not to put you on spot. There's only 2 people in class right now, so. Right. Mm-hmm. And what would that be analogous to, slope or intercept? Yes. Very good. And so when we're looking for when we're looking at a situation that where an item has 5 possible response options, how many factor loadings and thresholds would be estimated? Anyone in class would like to respond? I see some responses coming through chat as well. We'll let those come in. Right?
Can you repeat that for the audience?
Oh, yes. So a rumor said that there are 4 thresholds, which I'm seeing consistency in the chat here, right? Because we're taking the number of items minus 1, and then we have 1 factor loading representing all of those response options. So what we saw a lot in the solutions was that peers were saying there were 5 factor loadings with 4 thresholds. Is that correct? More than one factor loading, I think, is more the generalization there when we have a situation of 5 response options. So to expand a little bit on that idea, what if we have an item with 3 possible response options? And what, if you can say, would there be any considerations for identification there? So how many factor loadings, how many thresholds, and what would the implications for model identification be? We'll let some responses come in here. Anyone in the room would like to add? It's okay. Yes. Mhm. Right. So what terminology would we say is true for that situation? Well, yes, in terms of what type of identification. Yeah. So why do you say under-identified? Okay. So in the situation of 3 response options for the item, we'd actually be in a situation of just identified.
Wait, items or categories?
Response options.
It sounds like you're talking about number of items with identification.
Oh,
Because those rules still apply, no matter how many categories.
yes. Okay. Okay, then I think our discussion yesterday was off for me. Okay. You're right. Well, if it was 3 items, you would have the just identified.
That's still true.
And then if you had the 2 items, it would be dot dot dot. What broken, as you stated earlier. And in the chat, someone said for the 3 response options, we'd have 1 factor and 2 thresholds. How about for an item that has 2 possible response options? Right, awesome. So good extension, yeah, there'd be one factor and one threshold associated with that still. Great. Is there anything I should? Okay. So someone asked for the definition of threshold again. So just a reminder here that threshold does not equal difficulty and does not equal step parameters as well. I just want to make a note on that. In terms of the definition of thresholds, thresholds are the prediction of the lower categories compared to the higher categories. So here we're looking at sections or groupings of those categories. So say if we had 4 response options, we'd have various submodels. So one example of a submodel would be 0 and 1 in one grouping and 2, 3 in another grouping. This can be often confused with partial credit model, which is more of a piecemeal type model, I would say, in which your submodels are taking those categories separately. And so that's often a misconception and an important distinction to make between the partial credit model and the grade response model, where the grade response model is looking at the groupings of the categories, and partial credit model is taking those in piecemeal.
We haven't talked about that in this class yet.
Okay. Yes, the other thing to note is that we haven't talked about partial credit models yet in this course. It is coming eventually, perhaps today, but to be forthcoming on more information with partial credit models. That way you can see the differences soon. So, does anyone have any questions about question 1? Any residual questions? Rumors?
I was just wondering, you say talk about 2 response categories. Do you know any example, something like, I don't know, I never seen 2 categories.
If it, yeah, so if it was an ordinal case, right? I was thinking about that yesterday too. I think that was the question I was trying to get at, where what would it look like if you had 2 response category options that were not necessarily independent or not ordered response options, like a binary true-false, versus maybe a 2 response category that's not likely or likely.
Yeah, for binary, there's no distinction between ordinal or nominal. There's just one difference that's possible. So it is like a nested case of any of these other models in that sense.
Oh, okay. Does that help? Okay.
And I think Bladimir's question gets at the difficulty versus threshold task issue.
Yeah.
Yeah,
Good
of course.
segue.
Yeah.
Thank you.
Please take it away.
Yes, I have my tutbell here. Hi, everyone. So let's go to question 2 now. Please don't tell me that I cannot scroll down this. Not again, please, Lisa.
So it's a magic
I don't
mouse,
want to
only
waste
I can
time
I
here.
can only use it.
Yeah, I think so.
Yeah,
Maybe
what
we need
happens
some
is that if
classes.
it shuts itself off if you don't use it in a while. So that's the trick. It's not magic.
Wow, it is magic. Thank you, Lisa. So now, regarding question 2, it is in the IFA parameterization of factor models predicting ordinal responses, how do thresholds and intercepts relate to each other, and how do thresholds relate to difficulty parameters in the IRT parameterization? I read your answers. I think that they had a lot of things to emphasize. I think that they were good, but I have some tips maybe that can help you to understand this better. But in general terms, I think that you have the relationship between thresholds and intercepts. So let's split this question into 2 parts. And first of all, how do thresholds and intercepts relate to each other? What do you think? Yes, we have an answer. Thresholds and intercepts are inverse of each other. Yep. Any other comment about it? Do we have a clear idea about that? However, now, yes, exactly. People on Zoom, yes, they are inverses. Thresholds are penalty measures. and intercepts are easiness. Okay. Okay, that's interesting because in the case of thresholds, to me, and as we have seen in class, thresholds are related to the idea of easy, of hard items. Yes. Yes, because high values in terms of thresholds mean that the probability of responding 0 is higher than the probability of responding 1. But that's true in the case of binary variables. So we saw that for binary models, when we had just two responses, thresholds were the expected probability of responding 0 instead of 1 when the factor or when the latent trait or when ability was 0, right? Intercepts, you can multiply thresholds times -1 to get the intercept, which is the expected probability in logit or probit of responding 1 instead of 0. So all of your comments are correct in that sense. Now, when we talk about ordinal responses or ordinal predictors, there is a substantial difference to me, which is the number of categories or the number of submodels that we have. Because before, for binary items, we had only one submodel, and we were analyzing the probability of responding 0 or 1 or 1 or 0. However, now we have this idea of lower versus higher, and that depends on the number of categories we have. So let's say that our variable has 4 categories. How many submodels we will have? C minus 1, where C is the number of categories. So 4 minus 1 is 3. 3 intercepts or 3 thresholds or 3 B parameters that we will have in our model. So one of the differences to talk about thresholds or intercepts in the things that we are covering now is the number of categories or submodels we have, okay? Now, we can have different number of responses in our items, right, in the same model. Why? Because when we are estimating our model, let's say that we have 2 items. One of them has 3 categories, the other has 4. We can have both in the same model because, for example, M+ can estimate different thresholds based on the number of categories we have for each item, right? Yes. Any other question related to this first part? How do thresholds and intercept relate to each other? Because virtually we are talking about the same things as before. 0 instead of 1s now is lower instead of higher for thresholds. For the case of intercepts, was 1 instead of 0, now is higher instead of lower. And that higher or lower depends on the number of categories we have for the items we are working with. Okay? So I think that we are okay with that. But do you have any comment or additional question? Are we okay? Yes? Yes, sir? Great. So now, with respect to the second part, how do thresholds relate to difficulty parameters in the IRT parameterization? What do you think about it? What would you say about this question? How do thresholds relate to difficulty parameters in the IRT parameterization? We have one answer, thresholds equal to difficulty times discrimination in the IRT parameterization. Yes. Any other comment?
The difficulty is when you have a theta of 0, and the threshold is when you have the predicted probability of 0. Other way? Okay.
Yes. Yes, but good try. So, both thresholds and difficulty parameters for each item, they are saying something about items or people when something is 0. Okay? So threshold will give us the expected probability of responding the lower thing instead of the higher when the latent trait or when the ability is 0. Okay? Now, difficulty parameters will give us the estimated theta or the estimated factor needed to have a 50% chance of responding the lower part versus the higher part. And I'm talking about parts because we will have as many parameters as submodels we have. So let's say that our item has 3 categories. So we have 2 submodels differentiating 1 versus 2 and 3, and the other part is helping us to see what's the probability of responding 1 and 2 instead of 3. So we have 2 submodels there, but B parameters will give you the estimated theta or the theta needed to have a 50% chance of responding in each submodel, the lower versus the higher part, right? So that's the idea. But as Mubarak said, in the IRT parameterization, someone is waiting, yes. In the IRT parameterization, we can multiply the difficulty times the discrimination to get the threshold. And you will see in our next homework that sometimes when we use WLSMB estimation methods, so we have thresholds and factor loadings, but slopes. We can take the specific threshold and divide it by the item slope to get the B parameter. And I think that we have not covered that yet.
We started last time.
Yes, yes. So based on that, you can see the relationship that we can establish between the IFA parameterization and the IRT parameterization, similar to what we have done before, but now we are just changing our binary variables or predictors, well, binary responses by ordinal ones. But virtually, we are talking about the same thing because we have submodels, we have thresholds or intercepts, we have difficulty parameters or factor slopes or factor loadings. Any additional comment, questions, things to repeat? What do you think about it? Is everything okay? A lot of words, I know. A lot of things to pay attention to. But please, if you have something to tell, just say it, okay? Nothing here? Are you okay? Great. Do you have something else to say, Lisa? Thank you. Thank you so much.
Thank you.
A lot of things to say, yes, we could say that. Hi, folks. Thanks for playing along. We will go back over the graded response model again today because that will, I think, help differentiate it from the partial credit model, which we haven't talked about, but I know folks in their answers had indicated things related to that. So question number 3 is a true story. This is a direct quote from an email that I was forwarded by a student who took this class at a former university when they asked their advisor about what they should do in terms of a paper to report on the psychometric properties of a new instrument they were helping develop. So this was the advice that they were given. For an article introducing a new scale, you should just focus on reliability, validity using focus groups, correlations, and so on using classical test theory. CFA is only there after a well-established construct. IRT is too complex and is not needed. So, how would you respond to someone who has this perspective after what you've learned thus far this semester? I read your answers, so I know you all have some. And updated grades, by the way, as well. Let the typing commence. Or you can talk. You know, we can keep it old school if you have a microphone that works. Speaking of which, I'll make sure my microphone is still working. It appears to be. That's always good. What do you think? No one knows what to say. Here's a comment. Knowing the factor structure is very important to know whether the scale is measuring one dimension or multiple. Absolutely. That's one big thing. So if you're trying to report on reliability, such as using our friend alpha, which unfortunately is still the most common thing ever, alpha assumes three things, right? Unidimensionality is the biggest part. Second comment here, items may differentially relate to the construct. Yep, that's the other thing that alpha assumes, is that all items are equally discriminating or have equal covariances with each other. And that there's no local relationships, no local dependency, no correlated errors. So without knowing those things from the results of testing a model, how would you know if your estimate of reliability is even useful, right? You can't have reliability of two things mushed together and expect that to be a useful variable in any kind of analysis. How about validity using focus groups? That's a new one for me. Presumably that's some kind of like ask experts if these questions look good, and if they say yes, it has validity. Is that how this kinda? Face validity, I think, or there's a word for it. It sounds nicer than what I said, like expert opinion validity or something.
The way that I saw it used, and because it popped up in a lot of the social capital stuff, was kind of like, okay, so we're asking people these questions, but how are people understanding the questions? And when we get them together, do they all think that we're asking what we're trying to ask? And then there were levels of like having experts involved. So like typically it was like a multi-stage sort of thing where they would get a bunch of experts together and ask them like, hey, what should we be asking? And then they would take it to people that like a similar group that they were planning to ask those questions to in the survey. And so I think I like that as like a qualitative researcher, especially because it kind of brings them together and it helps feel like the work is more grounded. Because, and I think this matters especially if you're doing anything cross-culturally or anything that's like being translated.
Yes.
That is where this stuff is particularly important.
Yes. So
in my opinion, whatever that's worth.
Yeah, no, I appreciate that. I don't see validity using focus groups as a bad thing. Like there's nothing that we've talked about that would replace that. And if your people don't understand the questions in the first place, then it's only going to go downhill from there. So that seems like a useful thing. Correlations. Presumably that reflects convergent and discriminant validity kinds of ideas, that your new measure is correlated in the right way with other constructs that it's supposed to be related to. However, what if your items are actually multidimensional? How do you think those correlations are going to turn out? They could be wrong for reasons that have nothing to do with validity and everything to do with multidimensionality. So yeah, the reliability assessment and relationships with other things are predicated on the idea that your sum score is an adequate representation of your trait. And so without the models underlying that, I think all of that is somewhat sus. CFA is only there after a well-established construct or theory. What do we think about this? You have a construct or a theory if you wrote items about it, right? You've got something to start with. My mantra is that you don't need to have the right answer, you just need to have a clue. If you have a clue, that you have an idea as to what you wanted to measure, you can set up a model to look at that and see to what extent you're right.
Isn't that also the point of doing CFA, is to help figure out your construct a little bit better? I don't know.
Yeah, exactly. So for instance, if you have a construct that has the word "and" in the title, it's not one thing, it's two. Otherwise, you don't need two names. That's a general principle I operate under. So yeah, I think to the extent that your model and the way the items relate to the traits is supported, that should lend theoretical support to what you're doing. That is not necessarily going to be the same across the lifespan. So for instance, in the adult development and in the child development literature, there are terms called differentiation and de-differentiation. And they refer to executive functioning as one thing in particular that shows this pattern. If you try to measure executive functioning in like 3-year-olds, all of the tasks load onto one factor. It's like, can they do this? Can they sit still long enough to answer the questions or do whatever activity you're doing? But as they get older, it divides into different aspects of executive functioning and its separate factors. And then once you hit older adulthood, it starts to come back together again. So differentiation meaning spreading out into multiple factors over time, de-differentiating meaning coming back together again. So that is tied to our theories as to how we think about executive function, but then also the data in terms of how that is likely to change, being indexed by changes in factor structure. So yeah, I think that CFA needs to be a part of the story from the get-go, but what about this IRT is too complicated thing? I think we can all agree that IRT is too complex. I think we can just take a position statement on that and agree, can we? However, why do you think I am torturing you with IRT right now? Is it just because I'm mean? Or I'm trying to challenge you? Is it going to get worse? No. I'm going to say no, but yeah, actually, probably. You can't handle the truth. Now, why am I doing this? Why am I putting IRT in the factor analysis class? This is a legit question. Yeah, what kind of item responses are most people trying to predict? They're not continuous, like ever. Even slider bars that are being used to make something look more continuous have endpoints that you can't go past. So my perspective, and the one that I hope you have by the end of this class, is that the type of measurement model that you need is guided by the type of trait that you're measuring, whether it's continuous or something discrete, and it's guided by the type of item response format. If you have items that are plausibly continuous and somewhat normal, CFA is a reasonable approximation, but if not, you need to be in the IRT family for binary, ordinal, or nominal. There's also other options for other kinds of outcomes that don't have special names, but they would be found within the world of generalized. So that's why. It's not because I'm trying to be mean, it's because you need the link functions and the alternative distributions if you're going to predict ordinal data. On that note, I am about 2/3 of the way through homework 3, and I think I've seen 2 people whose factor response plots actually didn't go out of bounds so far. So, like 2 is what of the people who turned one in, I should say. There's a subset of people who decided not to make the plots and just turn it in to get it done, and that's fine. But most of the time, for 4 to 5 categories, it will go out of bounds at reasonable levels of theta. So CFA and the linear model part of it is the problem. So I would say that IRT may be too complex, but it's going to be your job to explain why you need it and to help other people understand what the parameters are telling you, which is where we come in. So yeah, those are my thoughts on this. I think this was not good advice. I believe the last formative assessment is going to be an exchange that I had with reviewer 3 over a paper where you're going to help me answer them. So we'll continue moving in this direction of how to give real-world advice. Very common advice, unfortunately, yes. Now there is one big exception to this. Can you think of a situation in which I would be totally fine with just reporting like item remainder correlations and correlations of sum scores? What if you had 10 people? Or 20 people? A few of you have very small samples because you're busy collecting data or the data are hard to come by. You're not going to fit an IRT model on 10 people, and even Bayes isn't going to fix that. So if you have really small samples and classical test theory methods are the only thing you can do, then that's better than nothing. But you would want to be aware of their limitations. All right. Other thoughts or questions? Cass from the back?
Loading and thresholds, and I'm having difficulty calculating log likelihood when those get into negative. So I've been having to force them positive, and I was wondering if you had any impressions on constraints and setting constraints as to positive or letting them kind of flow negative and positive.
Okay, so I'm not sure I understand the question, so I'm going to repeat it for the recording's benefit and for my own processing. So if you're putting a constraint, say, on a loading, like you want to make all the loadings equal to each other, and you're saying you're having a situation in which it wants to go negative,
When I simulate and allow those loadings to be negative, the log likelihood complains.
okay. So I think I understand.
But I know we have the assumption that the loadings would be equal, right? So
Mhm.
is that also assuming that they're positive?
So not necessarily the loadings are going to be, hey, come on, positive. Okay, my room is going crazy here. Stop it. The problem is that the factor may not know which way is up if you have items for which a higher score means you have less of the factor. So if you have like what would be called reverse coded items and you don't flip them around to all be going consistently, then the latent trait isn't going to know whether it goes such that a higher trait means that you're higher on the answers or a higher trait means you're lower, because it's true for both of them. And so it's called, I think, label switching. There's a term for it in Bayesian where there's like two caterpillars that are floating across. I don't know the right word for it, but I know the picture. That's what is essentially happening in that case. So what you could do is change some of them around so that they're all internally consistent, which is what I would do first. Alternatively, you could change your method of identification so that the common loading is fixed to 1 and make it positive, and then estimate the factor variance instead. And that will make it go the right way because you're nailing down what that constraint item should be.
And so then constraining, I'm looking at my sticky note. Because I have a grid of just discrimination difficulty threshold now. So if we constrain that threshold, and when thinking about, when constraining the loading, that threshold doesn't necessarily have to be constrained to be positive, it could be negative.
So thresholds would rarely be constrained. The only time that I would see that is in an invariance setting, which is starting probably not, maybe Thursday, maybe next week, where you're interested in asking the question as to whether the measurement model parameters are the same across different groups or occasions. And in that case, you might constrain the thresholds equal across groups and then see if that makes the model fit worse. But within a model, there's not like a Roche model like analog. You wouldn't constrain the thresholds equal to each other, and that would actually break it if you tried because they have to be ordered given the model. Yeah, so in terms of model identification, if you didn't want to have a factor mean set to 0, the alternative would be to fix one threshold to 0. But then that's just creating a different reference point for the scale. Sure. All right, anything else before we jump back into polytomous data? And also example 6a, I need to get that open. Looks like that one didn't open yet. Okay. So let me go back to graded response model land. This is where we were before, and of course, this one little paragraph always, come on. The text moves over every single time I open this presentation, and it won't move back. I have to do it manually every time. I don't know why. Certain slides are haunted that way. But this is slide 9 in lecture 6. Yes, example graded response model. So this is the version that I was calling 2P-ish because it's analogous to in binary data where we would have the 2-parameter model, either a 2-parameter logistic or ogive, where each item gets a different discrimination and in addition to having different difficulties. So the analog to that then is this model here, which has A sub I. So the top part of this is the IRT parameterization, where there is a common A across all 3 submodels for this 4-category item. That means that we are assuming that how the trait predicts the higher response is the same, regardless of which higher response we're talking about. So it doesn't matter if I'm talking about the logit of y greater than 0 greater than 1 or greater than 2, it's the same A regardless. Theoretically, you could change it, but it would take a lot of data and you'd have to write some kind of custom software to do it. Some kind of custom estimator, I should say. B, on the other hand, these are the difficulty estimates. Those are submodel specific and item specific. So this is in the formative assessment today. It's always number of categories minus 1 would be how many different B values you need. And these are called difficulty still, like that is the term for them, and they are indices of difficulty such that higher means that you are less likely to endorse or have a higher score. So they're more severe the higher these are. So in this model, B has a very specific interpretation. Do you remember what it is? From like 15 minutes ago. We're going to do it again. We're just going to keep doing it over and over and over again until you can say this in your sleep. What is a B parameter in these models? And feel free to read from the slide also. Roomers or Zoomers, you take your pick. B is when the factor is 0? Not quite. I think you're thinking of a threshold. So thresholds and difficulty parameters are related to each other, but they're not synonyms. They're each tied to a different 0 as a reference point. Another answer, amount of the trait needed for a 50% probability of the higher category. Why, yes, that is correct. Amazing. That's almost exactly what I would have said. Oh, someone gave you a pizza for that. I can only think that's a positive endorsement. If you pizza someone, is that a good thing? Is this a new lingo? Okay, good to know. My classes are the only chance I have of keeping up with pop culture. So you guys have a very important role to play in my life as an old person. So yes, B's are tied to y equals 0 in logits or probits, which corresponds to a probability of 0.5. So each of these B's tells you how much theta you need to have a 50-50 shot of moving from the lower categories to the upper categories as a whole. So 1, 2, or 3 in the first submodel. B is where the probability of any of those 3 choices is 0.5, like as a set, like lumped together. 0 versus something higher than 0 is the way that this works. So for what kind of person is this first submodel most useful is told by B1. So it's still the same idea as in binary, but that there are multiple B's per item in this case to cover the transition between cumulatively ordered categories. So B tells you who that item and who that choice is for, essentially. And if you write it out in terms of predicting probability, it looks like this, the same as usual. E to the logit over 1 plus e to the logit as our inverse link function. Okay, I like B's. So to me, like the factor analytic parameterization is just a way to estimate the model using M+, and I get the B's out myself because they're much more useful. Thresholds are not as useful. Okay. So B, another way to think of B is where A is, cough, cough, homework question. The location is where the slope is the strongest in binary data, and it's the same slope across in ordinal data as well. That's another way to think about it. IFA version then. So we replace A with a factor loading, and as long as the factor variance is 1, it is going to be the exact same number. A and factor loading will be the same. They get rescaled if the factor variance is different, though. And threshold here is given by this tau sign with the negative in front. Okay, so in order for the model to predict the upper category, we have to get rid of the threshold and turn it into an intercept, essentially. So -1 times the threshold is taking the place of where an intercept would be. That way, the intercept predicts the logit of the higher category. The factor loading predicts the logit of the higher category as well. And indirectly, you can get the probability of any one category by working across the submodels as shown here. Okay, how are we doing, folks? So in these models, B is tied to 0.5. That is going to be an important distinction for other comparison models. Okay, questions or any of that you want to hear again or differently? Pictures? Sure. So these are cumulative item response curves for an item that has an A of 1, and then the point where the curve intersects the probability of 0.5, y is 0, that is your B value. Here's a steeper curve, same premise. You can then compute the predicted probability of any response as a function of theta using that information. So here's the conversion for how you would get that across the submodels, and M+ will make pictures like this for you. Most software will, in fact. Here's a bad item, nice and flat. The middle categories are not differentiated. So this is an item, the worst case scenario that you would have would be something that is completely flat in terms of these slopes, right? It's not related to the trait at all. That's the worst. This is heading towards that direction. We talked about this last time. Do you want to hear about this again, or are we good with this? One more time, please. Sure. With Phelan. So this is from Real Data, a project that I did helping someone evaluate a new scale. And this is part of the report that I gave them. The top panel, the red bars, are differences across items in their discrimination, where higher means the item is more related to the trait at its B locations. The bottom plot has the trait on the y-axis, and the x-axis are the different items for these 6 different subscales. Each of these dots inside this plot, blue, green, and orange, those are the B values that I computed out of the thresholds and loadings so that I could describe the trait level at which you have a 50-50 probability of shifting into the higher response category. Wouldn't be class if my computer didn't try to restart itself in the middle of it. Remind me again in 4 hours, always. So for instance, the blue ones tell us the theta value needed to go from never into something greater than never. So never has a probability of 0.5, something greater than never, which is seldom, sometimes, and often has a probability of 0.5. Green tells us about where never and seldom transition into sometimes and often. And then orange tells us never, seldom, sometimes versus often, where often would have 0.5 probability at the orange locations. And the point that I had wanted to make in my report and to y'all is that this pattern of where the items are located is directly informative as to where your test is going to be reliable. So you need items that cover the entire span of the trait to measure everyone well. This y-axis starts at -6. That's not a very common trait level if we have a mean of 0 and a variance of 1, and it goes up to 2, but the only items that approach that have B values around 1, like there's just 1 or 2 here. So this compromises reliability on the high end of the trait because there are a bunch of people who are going to answer, I do this often for every item, and we can't differentiate just how high they are. So how do we fix it? My recommendation, add a higher one. There's only 4 choices here. If you add something beyond often, then that will take over the upper range of the trait and be more useful. Okay, now, then we had started looking at the M+ stuff. Shall we do that? M+ stuff, so that you can do your homework, which is not due until next Wednesday, because we haven't finished the example that goes with it. All right, please open. There we go. My computer is being sluggish, as usual. Maybe it's a metaphor for all of us. Hey, did you know there's only 5 weeks of classes left? The countdown has begun. I don't know. It helps me psychologically to have a countdown. I know that all the work doesn't necessarily stop, but it's nice to have some things that stop, right? Like it's finite, it's over in 6 weeks in total. So we started looking at this example. These are activities of daily living in older adults, And this is an ordinal response format that ranges across can't do it, big problems doing it, some problems doing it, or can do it. So there's still 4 choices. The highest frequencies are in the last category, so this is a relatively able sample in terms of the items that they're able to accomplish in their daily lives. We've got polychoric versus Pearson correlations here. Polychoric is going to be a better measure, particularly for ones that are range restricted. So this will be one of the things that in your next homework 5 I'll ask you to do, is to show me how different the estimates are relative to what you found in 3 if you actually fit the right kind of correlation matrix. We started looking at the code to estimate these models. So categorical is the magic option that allows you to run IRT models in M+. And it doesn't know or care how many categories each item has. It will figure out how many there are and estimate as many thresholds accordingly. So that's not something you need to tell it. This is helpful not only for items that are deliberately different. So like some items might be legitimately binary, some items might need 3 categories or 4 categories, or they may turn out that way because some people didn't use all the categories, particularly for items that have a high level of severity. You may not have people in the last response category. So if that happens, it's not a problem. In these models, though, M+ will not give you the IRT parameterization. I don't know why. So I had to develop a workaround using model constraint that does the math for you. So in this code, do you remember what's in parentheses? What that does? Constraints or labels or both, one of the two. And in this case, I have 7 labels that it is going to be creating. Yeah, labels in this case. So the 7 labels apply to the 7 factor loadings that are being estimated. So these are just labels, these are not constraints. In contrast, if I go to the other model on the right-hand side of the page, I have a single L here. Is that a label or a constraint or both this time, if I have just a single one? Yeah, this one's both. It is saying, hey, I'd like you to take that first loading and call it L. And do the same thing for the second, the third, fourth, fifth, the sixth, seventh. So that is a constraint and a label in that case. Labels are needed to make M+ do math for you. So this is also labeling the thresholds, so that down here I can compute discrimination parameters and I can compute B difficulty parameters. And these are the full versions of the formulas for your reference in case you have a model that is not identified with the standardized factor. So if it is, then a lot of this drops out and your difficulty is just threshold divided by loading. So this is what you will do at the end of your process, okay? You do not have to do this to start with. Part of the issue is that if you're missing some and you ask for it, it will yell at you. So it can be quite tedious to type out all of the separate thresholds if they're not regularized like this. I got lucky in these data that I have everybody in every category for every item, but that may not be true for you. So I would not do this until the very last step. Same thing on this side, where the only difference is that I have 1 loading instead of 7, so I would call this a 1PL-ish kind of model, or I named it the constrained graded response model, because it is nested within the version that has 7 different slopes. Okay. This is all the model fit information that we have because we're using full information maximum likelihood. So we will not be able to tell whether or not the model actually fits with this. That's why the alternative estimator, WLSMV, we'll use at the end of this handout. But 2PL does fit better than 1PL. Different slopes for different items are needed. Okay. Then we have the factor analytic solution. These are the factor loadings. They are the same thing as the discriminations. So it looks like item 7 is the worst one based on this number. Just numerically, it has the lowest. Does that mean that I should get rid of it? I don't think so. Number 1, it's still significant. So it is contributing. Number 2, is 7 a bad item for everyone? What do I need to know? What else has to be part of the story when I'm considering these factor loadings? The difficulty. Yeah, who is it good or bad for? Unfortunately, that's not what this means. These are thresholds. Thresholds are in the same direction as difficulty, but they tell you the predicted logit of the lower category when theta is 0. They do not tell you who the item is for. But if I take this threshold and divide it by this loading, I end up with the IRT solution that I asked for using model constraint. There's the result. So if item 1, for instance, is designed for the difference between can't do it and big problems doing it, requires a theta of minus 1.4. So somebody with relatively low ability, then that's where that transition is most useful. If I go with item 7, that's the last one in each of these. Note that it looks fairly different than the others. Item 7 has more negative difficulties than the other ones. So is item 7 easier or harder than the other items as a task, if its difficulties are more negative? Easier. A more negative difficulty means easier. It does not take much trait to be able to do this item, and each of these levels of being able to do it, I should say. Down here, I have how you would put the numbers into the equations. So for instance, if I wanted to predict the predicted logit given any value of theta for the first item, the first thing that I need right here is an intercept. Where that came from is this number right here, which is a threshold. So minus 9.8 is the predicted logit when theta is 0 of the lower category. I multiply it by minus 1 to turn it into an intercept. Then I can use the loading, which is the same, note that it's the same number across these 3, and multiply it by whatever value of theta. So like if I said if theta were 3, what would be your predicted logit or your predicted probability? You'd put a 3 in here. I have a couple homework questions like that. If I did the same thing with the IRT solution, it would look like that, where I would fill in the difficulty values per submodel instead, and A would be sitting out here, same as factor loading. Okay. So these two curves illustrating differences in discrimination or difficulty, or both. What do you think? Do these curves illustrate differences in discrimination or difficulty or both? Yeah, I say both. I meant for one, but the other is in there too. So the fact that the one on the left is steeper than the one on the right, what does that do to? Yeah, discrimination is the steepness of these things. Worst case scenario is that they're all flat, meaning no matter what your theta is, you have about the same probability of answering each category. So I intended for these pictures to illustrate differences in A as discrimination. However, and as noted in the comments here, yeah, didn't even notice the x-axis. That's because it's tiny font. But where the item is centered is illustrating difficulty. So this item, x-axis ranges from negative 3.5 up to 2.5, whereas item 7's ranges from negative 6 up to 3. So 7 is centered further over because 7 is a series of easier difficulty values. Here are item information curves as estimated by M+ and plotted in Excel. And the height of these is due to difficulty or discrimination. Stick on this theme. The height of item information is controlled by difficulty or discrimination. Yeah, still discrimination, same idea. Where it is tall, is that controlled by difficulty or thresholds? Change it up. Where it is tall, technical term, is that controlled by thresholds or difficulties? Got one vote for difficulty? Rumors, what do you think? Difficulties? TAs? Rest of the Zoom squad here? Yeah, it's difficulty. Yet another reason why difficulty is more useful than thresholds. And those information curves, if you sum them, create an overall composite known as test information that looks like this. And I have a reference value of 4 plotted here because that's where reliability would be 0.8. And this is another homework question asking you, given test information, to compute reliability, and here's the formula by which to do that. So these items are useful at measuring relatively low ability folks. They are not useful at measuring higher abilities. This curve is going to flatten out to 0.5 because of the way M+ computes test information. It has a lower bound of 1. So consequently, here's my plot of factor scores. Ginormous ceiling effect. Is that because I fit the wrong model? Should I fit a partial credit model instead? Should I fit a Roche model instead? No. Why does my picture look like this? The sample. Yeah, this pile of people right here are people who can do everything. No model can fix that, right? That's just, I don't have any information to discriminate across these people. So even though theta theoretically is supposed to be normally distributed in practice, it's not going to be. And I will remind you that this is not true theta. What this is an EAP factor score, meaning it is the mean of the distribution of possible factor scores for each individual. Each person has their own distribution as to what their theta could be, where the mean of it is given here, but the standard error of it is a function of test information. So I don't have it in this picture, but 1 over the square root of test information is your theta standard error. So you can picture like the inverse of it, where there's no information, there's very little information on the low end and the high end. The standard errors would be very large, and then the standard errors would decline as you get into the zone where we actually do have information. So this standard error right here is on average, but it doesn't hold for everybody. The variance of the factor scores is supposed to be 1. It's only 0.8 because of shrinkage. And this will happen any time that you don't have very many items, as well as when you have missing data that would differentiate the reliability across people. Okay. Here's some more pictures. Same type of plot as I made for the other project. So the top picture has discrimination on the y-axis. The bottom picture has the latent trait on the y-axis. And these colored markers are the transition points given by the difficulty parameters. So red versus orange here. This is differentiating people who can't do it at all versus can do it to at least some extent. That's red. And then can't do it or big problems do it versus some problems or can do it is orange. And then green gives us the last one, transitioning 50-50 split between 0, 1, or 2 versus 3. So each of these is not covering that much ground. Like if you look at these ones in particular, do you see how orange and red are right on top of each other? That's not good. that means there's very little range in terms of theta where you would pick one for sure and not the other. These categories are not very well differentiated. That's not true for all of the items, but it looks like it's true for the majority of them. So I would probably indicate this as meaning that these distinctions are too subtle and we might get away with fewer. You could also potentially expand the range of difficulty that is covered by adding something above the highest option of can do it, like can do it all the time, do it every day, that kind of thing. But back to the question of whether we should get rid of item 7, it is true, if you look at this picture, that item 7 is the least discriminating item. However, item 7 has difficulty covering a different point of theta than any of the other items. So if you got rid of item 7, you would be compromising your ability to differentiate among very, very low theta people. And you don't want to do that. All right. Yeah. All the words. This is the equivalent of me writing out the script of what I want to say. I just put it in the handout. All right. How are we doing? Okay enough? Yeah, no partial credit model today. That's coming on Thursday. I don't have a big example for it, and I don't have an example for nominal either, but I want you to have seen it at least, so we'll do that next time. Also, what we'll do next time is the WLSMV version of this model, which is basically the same thing except changing the estimator. And it necessarily changes the link function into probit instead of logit as well. So that's all we have left. Hooray. And as always, at the end of it, lots of words. So homework 5 template. Okay? You're allowed to use my words. But again, if I see activities of daily living anywhere in your project and that's not your theta, I will be very cranky. That's the trade-off. Seem fair? Yeah. All right. Any questions before we call it over for today? All right then, let's see. You can be working on homework 4. I will let you know when homework 3 is all the way graded. And let me know if you need anything or let the TAs know, okay? Hang in there. Only 4.5 weeks to go of classes. All right, see you all Thursday. Bye for now.